Approach. EDA approach studies the data to recommend admissible models that best fit the data. Focus. The focus is on data, its structure, outliers, and models suggested by the data. Assumptions. EDA techniques make minimal or no assumptions. They present and show all the underlying data without any data loss. EDA technique. Quantitative. Mathematical and statistical functions provide numeric outputs for the input data. Graphical. Graphical techniques use statistical functions for graphical output. The EDA quantitative technique focuses on numerical data. The first goal is to measure the central tendency of data. The second goal is to measure how spread out the data is. Click each title to learn more about it. Mean is the point which indicates how centralized the data points are. Mean is a suitable measurement for symmetric distributions. Median is the exact middle value of the observations and is suitable for skewed distributions. It's used to identify outliers in the dataset. Mode is the value that occurs most frequently in the data. Variance. It's approximately the mean of the squares of the deviations. Standard deviation. It's the square root of the variance. Interquartile range, or IQR. It's the distance between the 75th and 25th percentile. It's essentially the middle or 50th percentile of the data. There are some popular graphical techniques used to depict data. Histogram is very popular. The purpose of a histogram or BINS is to graphically summarize the distribution of a univariate dataset. It shows the center or location of data, the spread or scale of data, the skewness of data, the presence of outliers, the presence of multiple modes in the data. Another popular technique is scatterplot. A scatterplot represents relationships between two variables. A scatterplot can answer these questions visually. Are variables x and y related? Are variables x and y linearly related? Are variables x and y non-linearly related? Does change in variation of y depend on x? Are there outliers? Hypothesis is used in research and analytics to understand the relationship between dependent and independent variables. Hypothesis building can begin in the data exploration stage, but it becomes more mature and perfect in the conclusion and predict phase. Hypotheses are testable explanations of a problem or observation. Formulating a hypothesis is used for both quantitative and qualitative analysis to address a research problem. Hypotheses that suggest a causal relationship involve at least one independent and dependent variable. In other words, one variable which is presumed to affect the other. For example, holiday season in the year increases traffic and purchases on the website. An independent variable is one whose value is manipulated by the researcher or data scientist. A dependent variable is a variable whose values are presumed to change as a result of the changes in the independent variable. Let's now look at hypothesis building using feature engineering. Hypothesis building, a way to design models and predict the unknown, can be done using feature engineering. This includes identifying meaningful features based on data domain knowledge, automatically constructing new features from the raw data based on domain expertise, constructing new features manually from raw data based on domain expertise. Hypothesis building using a model has three phases. The first phase is model building, which comprises identifying the best input variables for the model, judging if the model can predict the outcome for the given input. The second phase is model evaluation. It's a phase in which you train and test the model, changing different parameters used in the model, aiming for accuracy. This is also the phase where the performance is optimized for the following: model accuracy, model performance, model comparisons. The third phase is model deployment. In this phase, you have finished selecting the model you will use to solve the business problem. The output of the model will help you take better decisions through model prediction, model matching, or actual outcome meets the expectations. Population is a large data set, and samples are a part of it. A sample drawn from a population should have all the main attributes or features which represents the characteristics of the population. An ideal sample can be treated as the population itself, and the hypothesis outcome for a sample would hold true for the entire population. In the example displayed here, 2 samples are drawn from the population of a large dataset. Each sample has a mean. The process of calculating the difference between the means is known as hypothesis testing. 2 kinds of hypothesis can be made initially. Alternative hypothesis. This hypothesis indicates that the proposed model outcome is accurate and fits the data. There is a difference between sample data S1 and S2. Null hypothesis. This hypothesis is the logical opposite of the alternative hypothesis and does not support the proposed model. It suggests that there is no difference between sample S1 and S2. The process of hypothesis testing begins by dividing a big dataset into training and test datasets, irrespective of the size of the dataset. This is one of the best techniques to design an accurate model. The training dataset is used to build a new proposed model. It makes use of the available features and responses of the data sample. The test dataset is used to test the proposed model. The test dataset acts as new unseen data. The null hypothesis that was formulated will be proven right when the proposed model does not predict better than the existing model. The alternative hypothesis will be proven right if the proposed model predicts better than the existing model. Typically, the training dataset size is anywhere between 60 and 80% of the big dataset, and the test dataset ranges between 20 and 40% of the big dataset. The last step is communication, where the analyzed data is formally presented to stakeholders. Use of several data visualization techniques make the communication effective. Data analysis can be presented in various forms, such as visual graphs, plotting maps, creating reports, writing a white paper, or even through a PowerPoint presentation. Data visualization techniques are used for graphical representation of data and are powerful tools for effective communication. Following are the main benefits of data visualization. Simplifies complex quantitative information. Identifies the relationship between data points and variables. Identifies patterns in data. Establishes trends present in the data and guides the analysis process. Here are some examples where data visualization can be applied. If you want to present information about new and existing customers and their behavior when they access your website. If you want to see web traffic patterns for the website, for example, more activity on the website in the morning than in the evening. Let's now look at plotting, another effective data visualization technique. Plotting is a data visualization technique used to represent underlying data through graphics. This is used often in data analytics. It can be understood as a coordinate system like x-axis and y-axis that represent variables, and you can mark your data based on the dataset and a mathematical equation. The process of plotting is also like telling the story about your data through different colors, shapes, and sizes. You can also show the relationship between variables through plotting. For example, the value of x changes if the value of y changes. Based on this information,